very simple. It's not complex. Okay? Not try to eliminate it by this. Okay? So JUnit has different packages. Okay? They put different APIs in different packages, just like what you do when you write the Java program that is more significant, right? You need to put, when you have more classes, you need to group that, okay, to packages. Okay? So work.JUnit, this package has the core classes and annotations you need to use. At test, we have seen that basically indicates that the method is the test method. It's going to be picked up by JUnit and executed by JUnit. Before, after, test setup, test up. Before class, after class, so it's going to do class wide. Okay, setup and we're going to discuss details, examples you see in this queue. For short, as you know, after you run the method, production method, you have to check the result. So that's the for sure we're going to discuss that. That's one of the major features provided by JUnit. Assume is a precondition. Okay, we're going to discuss that in detail as well. At a high level, this precondition has to be satisfied for the test method. Makes sense. Okay, it's meaningful. Then we have the runners. Okay, we have the runner package. This package includes classes to run and analyze the results of the tests. Okay. JUnit core, we have seen this one in the script. That's the main class we're going to use when we run JUnit. And when we discuss details of that. There are different runners. This is the interface that is defined in this package. The implementation of this interface, which basically are different runners, will be output in a different package. The runners will be discussed this test runners so that we can manage the automatic execution of test methods. The result, okay, when you run the test, run a set of test cases, you want to get the results, which like the failure information we have seen. Those information is returned or stored in the result class. We will see an example using that. And the run way, you specify different test runners. You have different ways to manage the executions of the test methods. A notification package that includes that provides information about the test run. Okay. So that like the failure, you have seen that. We're going to see that in the code right in the demo. Okay. Run listener is kind of like you can register listener so that you can take actions. For example, we have a failure, you can do some user-defined actions. We're going to probably we're not finished. I'm not working. I think we're going to have an example of that. I mean, in the code, probably have the run listener machine. Then, other packages. We have seen this, right? HemQuest, okay, the jar file. Okay, there are two jar files. You download JUnit. Okay. One is JUnit jar, the other is the HemQuest. So HemQuest, is that an English word? Probably not. So what they do is that basically they are matchers. They just want to confuse people, so they reshuffle all the characters in this matches word, this word. Okay. So they put HemQuest, just a different, just reshuffle the address. That's what this hack people do, right? They don't want you to understand what this package is supposed to do. But it basically matches, okay? They provide different APIs so that you can compare expected output against the actual output. that's what this package. So we're going to discuss in more detail. We're going to see some matches as well. Okay. To really help you to do the test evaluation. So the first two packages are from that jar file. That is a third-party jar file. It's not part of JUnit. And JUnit itself also provides some matches, but not as advanced matches as what you have in third-party jar file. That can help provide more complex matches. So that's kind of a high-level overview, okay, of the major APIs packages. So what we're going to do next is to look at each application, so that you can get a better idea about what is provided by JUnit. So before, after, okay. So this basically, if a method is annotated with before, it means JUnit, when JUnit tries to execute a test method, right? JUnit will always execute this setup method first before it executes any test method. So this happens inside JUnit. You just tell JUnit, this method has to be executed before any test. If you want to execute test method, JUnit is going to automatically execute setup method. And after you finish the test method, JUnit is going to automatically execute the method that is designated as add-out. That's basically what JUnit does. It's set up and clean up. The example here would be, for example, you have to open a file. Okay, so if this method is read, you want to test read or write, right? You have to open the file first. And after you finish, you have to close it. So that would be an example. So you don't have to, it's really a convenience method. You could say that I don't need these two methods, right? I can put the open clear like close in the end of this method. You could do that. But the problem is that if you have multiple methods like read, write, append, you have to do that in every test method, right? So this really, to me, is a convenience method. Okay. Again, you don't even need JUnit, right? You could write your methods by yourself. So it's a convenience, okay, method that can really help you when you have to do something over and over. So test setup, clean up is basically these the two methods are automatically executed before and after the test method. Then we have before class, after class, okay? So the difference is that this method before class is only executed once before you execute all the test methods. The previous one, before you execute any method, right? You can set up, you can execute before, after. So the difference here is that for all the methods here, okay, it only executes once. It's not if you have two methods, okay. This before class only executes once, no matter how many test methods you have. The previous one, if you have, let's see, if you have 5 test methods, you can execute 5 times. And you can do it for every test method execution, before every test method execution. This one is only executed once. If you execute all the test methods, this one is only executed once after you finish all the test methods. Okay? So this is kind of like system-wide setup, system-wide cleanup. Okay? It applies to all the test methods. And the example, the database. You have to log in first, but you don't have to for every test method you have to log in and log out. You don't have to do that. Okay, you only need to get to log in for the entire test session. Then assertions. Okay. that's for test evaluation, right? If you will understand how the test process goes, then you know the evaluation is very important, right? And assertion statements help you to do that. JUnit provides overloaded assertion methods for all primitive types. Objects and arrays. Arrays are collections of objects. So it has a lot of overloaded assertion methods. And the assertion method typically takes 3 parameters, okay? The error message. So this message will be displayed if the assertion statement finds like the expected output is not the same as the actual output. Find a mismatch, okay? Or the assertion fails, then you have to display this error message. Okay? Then you have the expected value have actual value. So assertion methods are just trying to check if they match with each other. If they do not match, you display that error message. If you do not have one, you will have a default error message. And typically, you're going to use a static import. Okay, that can really help you because you're going to do a lot of assertions. When you actually write real-life unit test cases, you're going to do a lot of checks after you execute the test method. So if you do not use this static import statement, what you do is that for each assertion method that is defined in the assert class, you have to have a class name. Okay, that is say assert equals, that is say assert dot, assert equals, assert dot, assert not equals, for example. Okay? If you do this static import, you don't have to use the class name. So again, it's a convenience feature. I mean, it's a Java feature, not a JUnit feature. So that you don't have to call it with the class name too many times. So there are different assertion methods, and for each assertion method, it has is overloaded so that you can apply to all the different data types: integer, string, array, whatever data type you have. Okay. So assert array equals. So basically, this method, as you can see from the name, right? You're going to pass 2 arrays. So this method is going to check if the 2 arrays are the same. Okay. You can see, well, I don't have to use this method. Right? You can give 2 arrays. You can check whether they are equal. What do? You have to iterate through the arrays, right? It's more work for you. You have to write a while loop, for example. And you have to do that in many places. So JUnit makes it more convenient. You have one method to complete 2 arrays. Okay. Assert equals, assert not equals. Okay, we're going to, you may say, well, why do I need both, right? I only need to assert equals. If not equals, I just negate, right? We're going to see why we want to do that. Okay. Assert same, not same. Remember, same means you point to the same object. Equals means you have 2 objects, but the content-wise, they are the same. Okay? That's the difference. Assert null, assert not null, assert true, assert false, assert that. We're going to talk about that. That's to make the code more readable. Okay, it's a very important concern. Okay? And the fail, we're going to see an example of that as well. Fail basically means the program execution cannot come to this point. Whenever this statement, this method is executed, something has gone wrong, and then your program is going to fail. Let me talk about assert that. Okay, it allows you to write more readable statements. Okay, so when you use assert that, you could say assert that x is 3. You can just read it out. You know what it means. Okay, and this is a matcher that comes from the HempQuest package or the JUnit matches. Okay, I remember that. But it's a matcher that you use. Okay, assert that response string either contains string color or contains string color different spellings. But as you can see, you can read it out. That's the whole idea of that. We got the matches, okay? So that my list has items 3. Very straightforward. The matches can be created and will combine together. We're going to probably come back to this issue. I just want to make a comment. Okay, in general, making your code readable is very important. Okay, how many times? I mean, when you go back to the code, some code that you have written some time ago, you don't know what this is supposed to do. You forget. Okay. What you were thinking, right? And not to mention other people. Okay, when other people read your code, if the code is not readable, people cannot make changes to the software. Okay, not maintain the software. So readability is very important. Okay, in our context, because we do a lot of like assertion statements, if the assertions, okay, are not written in a readable manner, it can make your test cases very difficult to understand. So that's the example to show the difference between assert that and the assert true method. Assert true is probably more like, I guess, simpler, right? If you look at the name, you know it's going to check whether the condition is true or false, right? So you give a condition assert true. So if you look at these two ways, okay, to do the same check, right? So this one, the top one, if the condition is not true, the failure message is just like this, assertion error. Okay. With assert that, okay, you get a more meaningful error message. Okay, that's like after you finish testing, this error message will help you to find what is going on, right? What has gone wrong, and to help you to debug. Okay, it's something that helps. Okay. So I guess the point is that assert that can also give you more meaningful error message compared to assert true. So sometimes we do expect the exception. Okay. How can you check that? Right? How can you check the exception is thrown not expected? So JUnit provides this support. So you can specify in the annotation. You can specify the expected output is the exception. Like in this case, if you access empty array, okay, where the array is empty, you don't have any elements. If you try to access, you're going to get the index out of the box exception. Okay. If you do not have that, you could also check like the exception is thrown as expected, but it's going to be more work for you to do that. Okay, so if you want to check this, so you have to have a fail statement. Okay, as I mentioned, whenever you get to the fail statement, the method, the whole program is going to exit. Going to fail, going to print out this error message. Okay. That means when you exit this statement, you're not supposed to come here, right? You're supposed to have the control flow is supposed to go to the attach block, okay? Then when you come here, then you assert equals, okay? Then when you come here, you say, well, everything is correct, okay? Otherwise, the test case, if you come to this point, the test case has failed. So it's more work. So when you have to do like the negative testing, when you do expect the exception, you can use this instead of doing this in this fail statement and the catch block. Assume, okay? So it specifies the condition that must be satisfied for a test to be meaningful. So for example, when you try to run this test case, try to calculate the total salary, okay, you have to go to a database and you have to retrieve all the records and do the computation. So as you can imagine, what you really want to check, if you cannot get a connection to the database, most likely it's not because of the method, the computation logic is not right, not because of that. It's because maybe some variable is right. So internet is not working. So in this case, what you can do is that you can say, you say, well, this test case makes sense only if you could get the database connection. Okay. So that you are not going to get confused, like if you could do that because of like maybe the internet was not available. Then you're going to say, well, you have so many test methods have failed. You're going to try to find out where the code goes wrong, right? So this will help you to deal with that situation. So you specify some conditions that must be satisfied before the test case is meaningful. Okay. Any questions before we? So assertions. So remember, JUnit provides 3 major features, right? As I mentioned last time. Anyone can remember what JUnit could do for us? 3 major features. Our lecture notes are structured based on the 3 major features. What is the first major feature of JUnit? As helps us to do. The 3 major features. Allows you to do common setup and clean up, right? That's the add before, add after. That's one thing JUnit helps us to do, so that you don't have to do it for each test method. That's one thing JUnit does. What's the second thing? Assertion statements, right? Helps you to check expected output against actual output. So it provides all those assertion methods that are overloaded. Okay, when I say overloaded, it means like assert equals. They have a method for assert equals for integers, assert equals for strings, assert equals for characters, assert equals for arrays. Okay, so they just overload the signature so that you can easily check different types of outputs. Okay? That's the second major feature. Okay? The third major feature, what is it? What does JUnit help us? It's to automatically run those methods, right? The test methods will automatically run. That's what we're going to discuss next. When you talk about different test runners, so that we can manage the automatic execution of the test cases. That's what JUnit does. Okay? JUnit is really, if you look at it from a high level, it's really a simple tool. Okay? But it helps people in practice. Okay? JUnit core, that's a main class that we're going to use, okay, to run JUnit. Okay? And we have seen that there's a facade for running tests, either from command line or from a program. So if you write from a command line, okay, then basically you're going to execute the main method in the JUnit class. You remember, like when you run a Java class at the command line, you're going to actually execute the main method, right? That's the entry point of your program execution. Or if you don't want to run from a command line, you can run JUnit core inside the code, from the code, we're going to see the example. Use this method, run classes. So let me go back to my example. Oh, by the way, I will, can you remind me, I will post the code to Canvas, the example code, so you guys can download and can play with the examples. Let's see. Let me switch to laptop. I will change it to mirror my screen. So this is what we have seen, right? So we are using JUnit core from command line. So basically, when I run this script, basically I'm executing this command. I'm giving the test class that I want to run as an argument to JUnit core class. So as you can imagine, this is just a Java class. When you execute this Java class, you're going to execute the main method. Right? And the main method is going to execute that test class. Okay? We have seen that. Okay. So what I'm going to do next is that I'm not going to use the command line. Okay. I'm not going to run JUnit core. I'm going to run the test class. Would that work? You have to have a main function, right? Otherwise, when you run this class, the Java runtime is going to complain you don't have a main method, right? So what we do is that we have to go to make sure we have a main method. I need to go to the test method. So here, if I use the JUnit core, if I give the test class to the JUnit core class, then I don't need to have a main method, okay? Because I'm not executing the test class. Now, if I execute the test class, I have to have the main method. Otherwise, you can try it, and we can try it now, but it will give you errors. It's going to complain you don't have a main method, right? Because I commented out the, if you look at the code, the script, right? That's what happens, okay? So now what I'm going to do is that I have to put the main method back. I'm going to give a main method to this class. And as you can see here, I'm not using JUnit core from command line. I'm using JUnit core from the programming interface, run classes. So I gave the test class to the run class method. The run class method is going to execute whatever it is supposed to do, to execute all the test methods. And you get the result. You have seen this class, right? Then you get the result. The result will have all the information output information from the execution of all the test methods. Okay. Then from the result you can get all the failure information. Okay. For each failure, you get a list of failures. Okay. Remember, like we have 2 failures. Then you can print out each failure information. That's what the main method does in this test class. Okay. So now with this main method, I think
You will have needed one more branch.
right. I need to add it back. Yeah. Otherwise, I'm not going to. So now I'm going to compile the modified version. Okay. Triangle classifier test. Oh, because I have the environment. I just set up the environment. So I'm going to just run Java C. It's going to compile all the code, recompile all the code. Then, now I can run JUnit core. Okay. So now, remember, the code is that I'm going to run the test class. This is the script I'm trying to execute.